Welcome back to the Circuit Reviver, where today we're going to be hopefully finishing off the Focusrite audio interface here. So it's been a couple of weeks and all of the parts have arrived. So this is a part 2 of the video, so if you've not seen part 1, I recommend you pop back and take a look at that, and I'll put it in the cards just up here. Now, there's quite a lot wrong with this, so there's quite a few components we need to replace. So we took off all these capacitors, they were fine, but we got them out of the way just because they were near some other sensitive components. So we'll start just by getting some things back on, I suppose. So I'll pull the scope round and we can start adding these bits back in. So here we are under the scope, and this will be our first component. You see the solder is just a bit all over the place here at the moment, so we'll just add some flux and we'll just try and smooth this area out a bit, and then we will add our components back in. So as I say, this device was sold as it supposedly got hit with a faulty USB and it sort of fried a bunch of stuff. So as we say, there's quite a lot that was wrong with this, and it's required a fair amount of work, but we'll see whether we can get there. So there's that part. Okay, so we'll get our hot air ready and we will use the hot air with this part. Okay, so I've just spanned the board around slightly just so it's in a slightly more comfortable place here, so I can actually get this. Okay, that's back on now, but as you possibly saw there, it did start to melt the plastic from the inside of the USB here, but that looks fine. Although I'm just trying to work out here, this resistor doesn't look too healthy. I'm just trying to work out if that's dirt or whether it's sort of split. No, that looks like dirt. So that looks sorted now. Again, just trying to work out whether that looks like a crack on that capacitor. Let's just get our meter in and just double check those then. Okay, here's our meter. What we'll do is we'll just put it into continuity, which is the mode that beeps when we have a complete circuit. And we'll just test either side of this capacitor and hopefully we won't hear a beep. Right, that's good. And then we just test resistance mode. And we'll just test either side of this resistor. Okay, that is in the mega ohms, which I do not think is right. So that should be 31 and one more and no more zeros. So I think that's... Okay, something tells me that there is a problem with that resistor. That's definitely not reading right. But the board is still hot, so it could be that. Okay, we'll bear that in mind. We'll come back to that because that doesn't seem right to me. And then we'll move on to our next component. So this one was the USB controller, I believe it was. Okay, so on to the next component, which is the USB part here. So this is a QFN, I believe is the type of component this is. So we've got that in place there, and I think I'm just going to come at it with some high but low speed air. Okay, I'm just trying to check those connections because I'm not entirely confident on them really. Okay, they don't look too bad actually. Let's try and see if we try and clean this up a little bit, whether they just look a bit stronger. So overall it's inside the little layout that it shows you. I'm just not fully sure whether every pin there is connected, but we'll keep moving along. So we've got two more, and these are two of the same component, these ones. So there's one that goes here. Okay, so that's the first one on. Let's get the next one on. Okay, so that's both those on, but I'm just not fully confident on the solder joints, so I'm just going to come in and touch these up a bit, just to make sure that they're fully connected. Okay, there's the first one, and then we'll do the same with the second one. Okay. Just clean up a lot of this flux, because there is a fair amount on here now. Okay, so that is the SMD components on. Now let's get all of the like these bigger caps and stuff on here then. So I'll probably just need to take a look back at some photos that I did before to remember exactly where each one goes. But you can see there's a series of capacitor gaps here where these go. So I believe this one here goes here, and then I think the two lighter grey ones go here and here. And then I believe the rectangular one goes here, and then the bigger one obviously here. So I'll just double check those photos and then we can start to get these in place. Yeah, so that is right, so we can go with this. Now fortunately the board lines up for us which way is which, so we've got like a little negative on the capacitor and then a positive sign on the board here. So we can just drop these in. And then all I need to do is just get my iron, and then we'll just tack these into place. So what I'll do with each of these to begin with is I'll just tack one of the legs down, and then I'll come back in afterwards and properly solder them in. So then that way they're just held in place. So there's that one. Then we said the black one was the one in the middle. So then that goes this way around, because the positive is at the top on this one. So we'll just tack this in place. Okay, there you go, that's just held in place now. And then we need to do the same for the others. Okay, that's all of the ceramics. Let's just double check where the blue rectangular one goes. Okay, so it goes next to this little coil here. So this goes in. If I remember correctly, I believe the way it faced was so that the writing was pointing downwards. So that just goes in here. And then we'll just tack this one down. And then we'll just add a bit of flux to this. And then we'll just flow that all the way in. Excellent, that's in. Okay, that's everything replaced. I think what we'll just do quickly is we'll just double check that resistor, because I'm not too confident on that. It was right in the path of everything else that got blown up, and it seems to be registering quite strangely, because that says 310 on it. And I'm fairly certain the way the code works is it's 31 and then the end of it tells you how many additional zeros there are, but I will just double check that. Just give this a bit of a clean up in here. If we just go back to our meter, the board is cooled down now, so we should get slightly more accurate reading. And if we go either side of that, that is showing in the mega ohms, which I do not believe is right. Let me just double check quickly what that component value should be. 31 ohm resistor. Now I don't have any 31 ohm resistors at that, so I think I'm just going to try and go for the one I've got nearest to it. So I've got either a 22 or a 47. So I think I might just try the 47, see what happens. Okay, so I need to be a bit careful given that I've already sort of melted this area slightly already. So I'll just get my resistor ready. Okay, there we go. It's the same size there, but it's definitely a different value. But I've not got any of those, so we'll just give it a go. Let's try and get this off. Okay, so that is all of the seemingly faulty components replaced. Let's just see what this 47 ohm resistor is showing in circuit, because it could just be that's the reason why it was in circuit, was showing a weird value. Okay, no, so that's definitely about the 47 here, so there's clearly something wrong with that resistor then. So that is all of the components that I found originally that were damaged replaced. So I think we're probably in a position where we can try and plug this in and see if it does anything. Hopefully we can still get the USB port in there now that it's broken. But I think what I'm going to do to begin with is I think I'm just going to try to plug it in, not plugged into anything. So I'll just go grab a lead, and then we'll just try run it off of a power bank to begin with, just to see whether we actually get any power into it, and then that way it saves all of my computer and stuff in case anything else goes wrong. Okay, so I've got a cable here ready. We'll try plug this in and see whether it does anything. So I'm not feeling too confident on this given how much was wrong with it, but let's just see if we get any signs of life out of this. What I'm going to do actually is, let me just get my USB ammeter. Okay, let's try this then. So USB ammeter is plugged in there. We'll plug this in 3, 2, 1. Okay, it's drawing not a lot, but we have lights and power. Okay, I wonder whether we try plug this in then and see if it registers. So I'll take the other end of this and let's stick this into the laptop and see whether it registers as a device. Okay, let me just see if I try add a device here, whether it shows. Do we still have... So the lights still turn on when we press them. Let's see if this will let me add it as a device. No, I don't think so. Let's try and unplug this again. Let's just see what devices it gives me. No, so it's not registering as a device, but we see as it comes in, like the lights flash. So it's doing something. You can see the LEDs there. I don't know how well they show. Are turning on. So part of this obviously is not working still. Okay, so I've done some testing around it. It's definitely not registering, even though all the light stuff are working. So part of this not wrong. I think we might almost need to call it here. But what we'll try last of all is just try with the thermal camera again and see whether we can see anything. Okay, so here we are just with the thermal camera, and if we take a look, there is a couple of things getting hot. There's this capacitor here, which we can take a look at. There's this chip here, which I don't know whether, I don't think it's one of the ones we've replaced. There's one of these chips here which we did replace next to a capacitor. There is, and then there's just a big dip in the middle of this chip here and right in the center of the main control chip. So feels like maybe the main chips might have gone on this as well, looking at this now that we've got like sort of power into it properly. This doesn't look too bad. It looks like sort of like cycling stuff. This very pinpointed dot in the middle of this doesn't look too good though. But we'll just take a look at these two capacitors then, because these are next to the two chips that we replaced. But this one's getting the hottest, so let's take a look at that. So I'll just take power out. Okay, so I've done a bit of digging around the board, and it actually turns out, so these things that were getting warm next to the chips that we replaced aren't actually resistors. So that's this component here and this component here. They're labelled up next to them with L, which is usually an inductor, and if we go either side of this one, we have something through it, whereas if we go either side of this one, we don't get anything through it. So there's every chance it's actually just the inductors failed. Oh no, just a bad connection, so that is working there. So I think we have to call this one here and say that this one is a no fix. Some good practice in there and some sort of like fun fault finding, but ultimately at the end of it, it still won't connect to the computer. And I think basically when the power surge fried all of the sort of like power rails and stuff, I think it's fried the main chip on this as well. But if anyone has any other suggestions of things to try, I will put this to the side and we can come back to it. But for now, I think technically we do add this up as another no fix. I think we may have already marked it like that in the original video, but I think it's probably only fair to change that to 10 and make that 20 to 10. So we're about 50-50 on our fixes versus no fixes. But thanks for watching, and we'll see you in the next one.